Welcome. In this video, we will solve an important 3D geometry problem involving a plane and its intersect with coordinate axis. The problem is a plane meets the coordinate axis at the points A, B, C. Then the centroid of the triangle ABC is given as alpha, beta, gamma. We need to show that the equation of the plane is x is divided by alpha, y is divided by beta plus z is divided by gamma, which is equal to 3. Solution. Let's recall the general equation of the plane is ax plus by plus z plus t, which is equal to 0. Next, since the plane cuts the coordinate axis on the x-axis, that is y is equal to 0, z is equal to 0, then we get a is equal to minus t is divided by a, comma 0, comma 0. Next, on the y-axis, x equal to 0, y equal to 0, then b is equal to 0, comma minus d is divided by b, comma 0. On the z-axis, then we get x equal to 0 and y equal to 0, then we get c is equal to 0, comma minus d is divided by c. Next, the centroid of the triangle. The centroid of the triangle ABC is given by x1 plus y, x2 plus x3 is divided by 3, y1 plus y2 plus y3 is divided by 3, comma z1 plus z2 plus z3 is divided by 3. Substituting the points, then we get centroid is equal to minus d is divided by 3a, minus d is divided by 3b, minus d is divided by 3c. The given centroid is alpha, beta, gamma. Equating them, then we get minus t is divided by 3a minus t is divided by 3b equal to beta and minus t is divided by 3c, which is equal to gamma. Solving them, then we get a is equal to minus t is divided by 3 alpha and b is equal to minus d is divided by 3 beta and c is divided by minus d is c is equal to minus d is divided by 3 comma. Substituting into the plane equation, ax plus ay plus z plus t is equal to 0. That is minus t is divided by 3 alpha x plus minus t is divided by 3 beta into y minus t is divided by 3 comma z plus t is equal to 0. Dividing throughout by t. Then we get minus x is divided by 3a minus y is divided by 3 beta minus z is divided by 3 comma plus 1 equal to 0. Then multiply by 3. Then we get x is divided by alpha, y is divided by beta plus z is divided by gamma, which is equal to 3. Thus, we have proved the equation of the plane is x by alpha plus y by beta plus z by gamma, which is equal to 3. Proved the problem. In the next problem, we will learn how to find the equation of a plane passing through a point and perpendicular to two given planes. The problem is find the equation of the plane passing through the points 1, minus 2, 1 and perpendicular to each of the planes 3x plus y plus z minus 2, which is equal to 0, and x minus 2y plus z plus 4, which is equal to 0. Solution. Let the equation of the plane be ax plus by plus z plus t equal to 0. Next, we recall the condition for perpendicular planes. If two planes are perpendicular, their normal vectors are perpendicular. So the dot products of normals is 0. Then we have the normal to required plane B, C. The normals of the given plane The normals of given planes 3, 1, 1, 1, minus 2, 1. Thus, we get two conditions. Two conditions 3a plus b plus c which is equal to 0. Mark it equation number 1. Mark it equation number 1. Then minus a minus 2b plus c which is equal to 0. Mark it equation number 2. Since using the plane passes through 1 minus 2 1 substituting into the equation, then we get a of 1 plus b of minus 2 plus c of 1 plus t which is equal to 0. That is a minus 2b plus c plus t which is equal to 0. Mark it equation number 3. And solving the equation number 1 and 2, we get 3a plus b plus c which is equal to 0. A minus 2b plus c which is equal to 0. Subtracting 2 from equation number 1, we get 2a plus 3b. 2a plus 3b which is equal to 0, which implies a is equal to minus 3b is divided by 2. Substituting into equation number 2, then we get c is equal to 7b is divided by 2. So a is, b is, c is which is equal to minus 3, 2 and 7. Take a is equal to minus 3, b is equal to 2, c is equal to 7. Substituting into equation number 3, then a of minus 3 of 1 plus 2 of minus 2 plus 7 of 1 plus t is equal to 0. Minus 3 plus minus 3 minus 4 plus 7 plus t which is equal to 0, which implies t is equal to 0. Substituting in the plane equation, then we get minus 3x plus 2y plus 7z which is equal to 0, which is the required plane equation. This is the equation of the plane passing through the given point and perpendicular to both planes. In the next problem, we will find out the coordinates of the foot of the perpendicular drawn from the origin to the given plane. The problem is find the coordinates of the foot of the perpendicular drawn from the origin to the plane 2x minus 3y plus z minus 7 which is equal to 0. Solution. Let the foot of the perpendicular be P of x1, x2, z1 be the foot of the perpendicular from the origin. Since P of x1, y1, z1 lies on the plane, then we have 2x1 minus 3y1 plus z1 which is equal to 7. Mark it equation number 1. Next, we recall the direction of perpendicular. The perpendicular from the origin to the plane is along the normal vector of the plane. The normal vector of the plane 2, minus 3, 1. So the direction ratio of the line OP So the direction ratio of the line OP of x equal to 2, y1 is equal to minus 3, z1 is equal to 1. Next, define let the parametric form. Let x1 is equal to 2k, y1 is equal to minus 3k, z1 is equal to k. Substituting into the equation number 1, then we get 2 into 2k minus 3 of minus 3k plus k, which is equal to 7. Then we get 4k plus 9k plus k, which is equal to 7. From this we get k is equal to 1 by 2. That is, substitute k is equal to 1 by 2 in the above. Then we get x1 is equal to 1, y1 is equal to minus 3 by 2, z1 is equal to 1 by 2. Therefore, the foot of the perpendicular is 1, minus 3 by 2, 1 by 2. This method uses the fact that the perpendicular direction is normal to the plane. Thank you.